So now we're talking about diagonals of parallelograms, and we have two properties, two theorems. The first one is if a quadrilateral is a parallelogram, then its diagonals bisect each other. And what does that mean to bisect each other? That means AP is congruent to PC, and also PB is congruent to PD. Right? It doesn't mean that AP is congruent with PD. Right? So they bisect each other, which means they cut each other into two equal parts. And then what? We also have that if we have a parallelogram, then the diagonals separate the parallelogram into two congruent triangles. So here we have a parallelogram with a diagonal, and so triangle ABD is congruent to triangle CBD. Okay, so those are congruent. ABD is congruent to CDB. Okay. Okay. So then we have this problem here, and we want to use these two properties, two theorems, to solve this problem. And we need to find the values of the variables, right? It says here x and y, but let's also find z here. So how can we start? We can start by finding y, and we know that the diagonals of a parallelogram bisect each other, which means TP is congruent to PR. So I'm going to put here TP is equal to PR. The measure of line segment TP is equal to the measure of line segment PR. Okay, great. So then now we can substitute in, and we get 2y minus 5 is equal to y plus 4. And then we'll do some math, and then we'll get y is equal to 9. Okay, so we found y. And then now we want to find x, and so x is here. And so how can we solve this one? Well, we know that the diagonals of a parallelogram split the parallelogram into two congruent triangles. So we know that QTS is congruent to RSQ, right? So I'm going to put that over here. I'm going to say triangle QTS congruent to triangle QTS is congruent to triangle SRQ. Okay. So then, since those two triangles are congruent, then that means via CPCTC that all the congruent parts are congruent, and so QT is congruent to RS, right? So we have QT, the measure of QT is equal to the measure of RS, and then we could substitute in, and we'll get 5x is equal to 27 divided by 5, and we'll get x is equal to 4.4. Give me 1 second. So we got 27 divided by 5. 5.4. So it's 5.4. Okay. And then lastly, we have this z variable. And our theorems here aren't going to help us, but the theorem that we used a couple chapters back, which is we have two parallel lines, because this is a parallelogram. This line is parallel to that line. So if we have those two are parallel, and this is our transversal, then we could say that this angle congruent to that angle, right? And why? Because they're alternate interior angles. So we could say angle, what is it? RQS is, or we could say measure is equal to the measure of angle QST. And then we substitute. So we'll get 33 is equal to 3z divided by 3, and we'll get z is equal to 11. Right. So we could use our theorems here to solve problems, and we could also use theorems from the past, right? The parallel lines cut by transversal theorems, and that's what we're going to do here on numbers 1 through 4.